Hi, my name's Mike Parsons and I'm the instructor for this course. What I'm going to do here is I'm going to make up a YouTube channel that has all of the content in the course in it. The intent here is to drive you in the right direction in your studies. So I'll be talking about assignments as they come up, and I will also be going through some course material where I might think there's holes in the content or where I need to emphasize certain things. Everything is broken up into units, so there are 5 units for the course, so this is Unit 1. The units are broken up into sections. They call these sections activities. So this is Unit 1, Activity 1. We're looking at qualitative chemistry and an introduction to chemistry. Now, once you go through the content, you have to go do some research. One person I might suggest is Khan Academy, K-A-H-N Academy. So if you do a search on Khan and you put in what it is that you're looking for, you can find material on that section of the course. Now, some people don't like Khan. You might find other videos on YouTube that suit your learning style. The first thing they go through in U1A1 is matter. So everything in our universe can be broken up into different categories of matter. So remember, chemistry is about the interaction of things that are all around us. So it could be things that are in the air, in the water, or on land. And that is all classified somehow. I would take that chart that they have in the content for matter and I would write on it. I would annotate it. Remember, this course is open book. So when you write tests, it's all about taking good notes as you go along. Now, the first thing I'm going to state is you should have a good periodic table and have a good couple of copies in front of you when you're going through the periodic table. I'm just going to go through a couple things that I think are important from U1A1. First of all, if you look at a periodic table, you should see the atomic number somewhere inside of the box. So for sodium, Na, atomic number 11 means it's the 11th element. It is the 11th element because it has 11 protons. So that's how we define what an element is. If it has 11 protons and it has no charge, so there's no charge given, that means it also has 11 electrons. Protons are positive, electrons are negative, and I'm going to review these in a minute. So this is 2 important pieces of information we can see by seeing that sodium is the 11th element. Take a look at a periodic table, find sodium, and make sure you can find that number 11. Now, another number that's important will be the atomic mass or atomic weight. And this will be like 22.9. And the reason it's a decimal is not every sodium atom is exactly the same weight, so it's like an average. So I just round that 22.9 up. So this is my mass. And if I subtract 23 minus 11, that tells me how many neutrons I have. So my short form here is neutrons. So every element in the periodic table is made up of electrons, protons, and neutrons. Protons and neutrons are in the nucleus, and the electrons are in the orbit. Electrons are very small. They're 1/1800 the size of protons and neutrons, and they have a negative charge. The proton has a positive charge, and the neutron, which is neutral, does not have a charge at all. So if we were to draw a cartoon figure of what an atom looks like, there's the protons and neutrons, and then the electrons are in orbits outside of the protons and neutrons. Guys, one thing that students tell me all the time about videos that's good for learning is you can go back over them. It's going to be really important to know how to find protons and electrons and neutrons in this course. So make sure you go back over that section and you can do that. You might also want to watch a video reviewing neutrons, protons, and electrons to understand what's going on. Electrons are the only thing in the end that count in chemistry because they're going to be the things that react. Ions mean things that have charges. Now you might ask the question, how do I know if something has a charge or not? You have to be told. So it will have to say 1 plus or 2 minus. In the periodic table, nothing has a charge. okay? So when they give you a question, they'll have to say lithium 1+ or oxygen 2-. To get your proton number, it is 3, because whatever your atomic number is always your proton number. To get your electron number, you would think it would be 3 because protons and electrons are always the same, but that doesn't count if there's a charge. 1+ means there's one more positive than there is negative. There's one more positive than there is negative. 3 protons, 2 electrons. To get our neutrons, you subtract 7 - 3, 4 neutrons. Let's do that again. Protons 8. This number is never going to change. You have 2 more negative charges than you do positive charges. So you'll have 10. 16 - 8 is 8. Now, we can change electron numbers. We would have thought there was 3, there was 2. We would have thought there were 8, there were 10. We can never change proton numbers. The last thing we can change are neutron numbers. So how do we change neutron numbers? This mass number has to change here. So if you watch a video on isotopes, you can learn all about this. Neutron number here would be 6, because to get to the neutron number you subtract. If you subtract the neutron number here, there's 8 neutrons. So iso means different, tope means atom, so we have a different form of the atom. Carbon-12 is your normal form of carbon. Carbon-14 is a radioactive form of carbon where the neutrons can break down. This is used in dating objects. You can look at the ratio of carbon-14 to carbon-12 because this will decay over time. Once again, most of your carbon is carbon-12. Carbon-14 is a rare version. As long as you understand that you can have different numbers of electrons, those are called ions or charged species, and you can have different numbers of neutrons, and those are called isotopes, different form of the same atom. These are the major parts of Unit 1, Activity 1 right here. Make sure that you go through matter, and make sure that you go through atomic number, atomic mass, electrons, protons, neutrons, ions, and isotopes.